This is lesson 4.1. We're going to talk about some exponential functions. Our goals are to be able to identify some key features of exponential graphs, to differentiate between growth and decay, and to describe some shifts in the graph. Exponential growth is something that we've talked about before. Linear, when we look at linear growth, it's a specific rate each time. So each time it's going up by 2 or by 3/4. Exponential growth is a specific percentage each time. So each time it increases by 10%. That allows you to grow more quickly, and therefore that's why the graph curves up quicker, okay? There's also exponential decay. They are both a percentage change. However, growth is a percentage increase, decay is a percentage decrease. So you can see here the red is the increasing, it's growing. Decay is the decreasing, it's the blue, it's going down. When we talk about exponential functions or exponential expressions, we have some vocab that we need to know. First of all, we need to know the base. The base is that number. Most of the time it's in parentheses, and the base is always positive, okay? You cannot have a negative base. It's just not a thing. If there is a negative, it means that actually the coefficient or the A is negative. Exponential decay will always have a base that is between 0 and 1, and its growth if the base is larger than 1. The exponent will generally be our variable, and then we have an answer, which is what it is equal to. So looking at these equations, let's talk about which ones are growth and which ones are decay. So we are looking at the number in the parentheses. In this case, the base is 9, which is much larger than 1, so this would be growth. Here the base is 1/2, which is between 0 and 1. This would be a decay function. And then 3/2. So I put this one in here because, don't get distracted by the fact that every fraction must be decay, because it's not. 3/2 is actually larger than 1. Therefore, this is also a growth function. Okay, so be really careful. It's about 1. If the number is less than 1, it's decay. Bigger than 1, it's growth. Okay, don't get distracted by the fact that it might or might not be a fraction. We can also look at the graphs a little bit. So I'm just going to graph you real quick this function because I want to talk about what this looks like and where the numbers come from. My expectation would be that we're using probably Desmos to graph this, but I just want to show you what it looks like, okay? So I'm going to start with 0, and I'm going to plug it in. So 2 to the 0 power, Let's try this again. 2 to the 0 power is equal to 1. 2 to the first power is equal to 2. 2 to the second power is equal to 4. 2 to the third power is equal to 8. Do you see how that's increasing really rapidly? Okay. Now to go backwards, 2 to the negative 1 is 1/2. Remember that a negative exponent means we're taking the reciprocal. So because 2 to the positive 1 is 2, 2 to the negative 1 is 1/2, which means that 2 to the negative 2 is going to be 1/4. And 2 to the negative 3 is going to be 1/8. Okay. Now, if we come over here and graph these, I want to kind of show you about, so 0, 1, 1, 2, 2, 4, 3, 8. That's going up pretty quickly. But then when we come to the other side and we start graphing left, so negative 1, 1/2, okay? Negative 2, 1/4, negative 3, 1/8. Do you see how that slows down a lot? And the thing is, it will get incredibly close to 0, but never actually touch, because you can never have 2 to any power that is equal to 0. It can get infinitely close, but you can never actually have 2 to the negative 100th power. Will still be a number that is slightly larger than 0, okay? So that's an important thing to note. This is actually an asymptote. We've talked about these before. Exponential functions have horizontal asymptotes, and this has a horizontal asymptote at 0. Now we can also talk about some different things about the function, such as domain and range, okay? The domain of an exponential function is always all real numbers. We could also say that it's from negative infinity to positive infinity. I am okay with either one of those, all real numbers, or saying the interval from negative infinity to positive infinity, okay? The range, not so much. The range is going to have a bottom, in this case, 0, because it's not going to cross that asymptote, okay? We talked about the horizontal asymptotes. So in this case, the range is going to be from 0, and notice I'm using a parenthesis because it's never equal to 0, but it does go up forever. So the range is from 0 to positive infinity, okay? And then the end behavior, we want to look at both sides. There's only 2 arrows here, so we only have 2 end behaviors that we're talking about. The first is as x approaches positive infinity. What is f of x doing? F of x is going up, so it is also approaching positive infinity. And then to the left, as x approaches negative infinity, what is happening to the graph? Well, it is getting infinitely close to 0 from the top. So we're going to say 0 plus. This should look familiar. I know you love this stuff from the rationals. We're going to keep using this because it is very important to understand what end behavior looks like, okay? Some key features of the graph that I want to point out to you is that a parent graph of an exponential function will always go through 0, 1, okay? Whether it's growth or decay. And that is because anything to the 0 power is always going to equal 1. And then we will also always have the point at 1, and whatever the base is will be another point on the graph, okay? When we start transforming graphs, we're going to look at some of that, and so we need to know how it moves up and down. We also have an asymptote for a parent graph at 0, and that is a horizontal asymptote. So remember, it's y equals 0, okay? That's an important thing to note. The asymptote will move as we change the graph. So we're going to talk about transformations. We've seen this a little bit before. Again, B is the base. H and K are the left and right and up and down. And then A is a stretch. Remember that if A is negative, then it is a flip. Okay? So a vertical shift, we can move up and we can move down. Plus K moves it up, minus K moves it down. So you can see that this has a plus K of 3. It's moved up 3. The asymptote goes from 0 to 3. This is a minus 3, so it's moved down 3. And notice that the asymptote is going down 3. That's a really good way to tell what's happening to the graph, okay? I also want to note, look at that point 0, 1. It's moved up to 0, 4, which is plus 3. And here it's moved down to negative 2, which is minus 3. A horizontal shift is H. Plus H moves left, minus H moves right, and that will be in the exponent. So this is x plus 3. So that is moving to the left 3, and then we have a minus 3, which is moving to the right 3. It needs to be clear that those are in the exponent. Notice that the asymptote has not moved. The asymptote is still at 0, and that's where it stays. All right, so we're going to look at this and we're going to describe the shift, okay? I've given both the equation and the graph of the parent graph, so you can kind of see like some of the important features to sort of talk about, okay? So let's start with how this is shifting. This is moving, this is moving down 3, and I know that from the minus 3. It is also moving left 1, okay? And the parent graph would be 2 to the x. So the base isn't changing at all. These are just the transformations done. It's moved left 1, down 3. Now let's talk about how that changes the domain, okay? So the domain is all real numbers. Does shifting it up or down or even left and right change that? Well, no, it's still all reals, okay? That doesn't change. The range, however, does, because remember that the asymptote is the bottom value of the graph, which of the parent graph is y equals 0. But if that's moved down 3, then our new asymptote would be at y equals negative 3. So the range in this case is now, instead of 0 to infinity, going to be negative 3 to infinity, okay? So when we have a vertical shift that moves the asymptote, that also changes the range values, which means, as I stated, the asymptote is at y equals -3. And then the y-intercept, which was at 0, 1, is also going to move down 3 to 0, -2. So with exponentials, we focus a little bit more on the y-intercepts, the y-asymptotes, versus with rationals, we were looking at some of the vertical ones. Let's try another one. Let's start with the shift, and I don't know what happened to my graph here, but we can see that this has moved up 4, and it's moved to the right 1. And the parent graph would have been, y equals 2 to the x, okay? So that means that the domain is still all reals. That has not changed. The range, however, has now moved up 4. So instead of being 0 to infinity, it's 4 to infinity, which means that the asymptote is at y equals 4. And then the y-intercept, which remember was at 0, 1, has moved up 4 to be at 0, 5. Okay? I hope we're starting to get the hang of this. We can also talk about the stretch or shrink a little bit. Okay? So when we have a stretch or shrink, it means that we're multiplying the whole function by a coefficient. So in this first one here, you can see there's a vertical stretch of 3 because I now have 3 times 2 to the x. This compression would be by 1/3 because I have 1/3 times 2 to the x, okay? If the graph gets steeper, that's a vertical stretch. If the graph gets less steep, that is a vertical compression. And you can see that it's an integer versus a fraction, okay? Or maybe I should say that differently. Greater than 1 versus less than 1 is a better way to say that. So looking at this one, do we have a stretch or a shrink? Well, we have 1/4, so that would be a shrink or a compression, a shrink of 4, okay? I know that sounds silly to say, but you're shrinking it by 4 times because it's 1/4. A shrink of 1/4 would actually be a stretch of 4. So it's kind of a little bit backwards of what you think, okay? The domain doesn't change. Notice every single time the domain is exactly the same. Because we did not have any vertical movement, the range is still the same as well, from 0 to infinity, which means that our asymptote is at 0 and our y-intercept is at 0, 1. Okay? So a stretch or shrink hasn't changed anything other than the rate at which it climbs. Okay? Now, the other thing we need to talk about are reflections, and this time we have 2. We have a horizontal and we have a vertical. Okay? When the exponent is negative, we have a horizontal flip across the y-axis. When the function is negative or the coefficient is negative, it flips across the x-axis, and that is a vertical, okay? So vertical is when a is negative. A horizontal is when x is negative. All right, that's maybe a little different than what we've looked at before. But that kind of gives you, I hope, a helpful hint of how to tell the difference. So here's kind of all of the different things that we can do to a exponential function to translate it, okay? So we can move it left, we can move it right, we can move it up, we can move it down. We can shrink, we can stretch. We can flip it vertically, we can flip it horizontally. And then this is sort of the general one. We oftentimes use H and K, okay? C and D are the same as H and K. Some books use C and D, some use H and K. They're interchangeable. It doesn't matter, all right? Things that you should take note of, the base is always, 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 always positive. So even that one that we had that was -2 to the x, technically that's -1 times 2 to the x, okay? That's an important thing to note. The y-intercept sort of helps you orient your graph because remember it's always at 0, 1. And then if there's a shift that moves. And then the domain is always -infinity to +infinity, or we could also say all real numbers, okay? Either one is acceptable. Let's take a look here at some graphs and we're going to see which equation best matches it. Let's start with, is this growth or decay? Well, it's going down, okay? So we know that this has to be decay, which means that A is automatically out. Now I want to talk about B for a second because we just discussed this. You cannot have a negative base. So this isn't even an option. Letter C, of course, the base is less than 1, which means this is a decay function. Looking at this one, we know that this one is growth because it's going up, which means that letter C is out because the base is 1/2. Now the question is, looking at the the equation here, sorry, either it has moved to the right one or it has moved down one. Well, I think we can see that the horizontal asymptote has not changed. It's still at y equals 0. So this cannot have moved down one. So then clearly it has moved to the right one, which kind of makes sense. You can see, don't be tricked by this graph, by the way, it's scaled by halves. So this is 0, 1, and you can tell that that's moved to the right 1, okay? So letter A is your guy there. I'm hoping that after this lesson, you feel like you can identify some key features, that you can describe transformations, and even that you can write or match an equation with a graph.